Stoa is a digital campfire where we cohere in dialogue about what matters most at the knife's edge of what's happening now.
Welcome back to the Stoa. My name is David McFadden, and I'll be your host today. If you're new to the Stoa, welcome. The Stoa is a place for us to cohere and dialogue about what matters most at the knife's edge of this very moment. I'm excited and only 10% nervous to introduce Frank Heile to the Stoa. Frank holds a PhD in physics and worked as a software engineer and manager in Silicon Valley for many years, now retired. This is the first session of a two-part series named Consciousness and Spirituality Explained. Next week, we'll meet at the same time and place where Frank will explain spirituality, which means this week we're going to hear all about consciousness. I think it's a fair warning to say that the model Frank is going to present today is fairly technical. I found it really exciting when I first discovered it a couple of years ago because Frank was speaking my language as a software engineer, thinking in terms of agents and data flow diagrams. But maybe you're not so technical, but I still think you'll find Frank's model very enlightening because it builds a bridge between cognitive science and phenomenal self-inquiry, which ties in really nicely with Evan's sense-speaking series called The Bridge, which he does on Mondays. But perhaps more importantly, it provides the necessary groundwork and foundation for his theory of spirituality. Looking forward to next week already. The format of this session is it will last for 90 minutes. The first half will be Frank presenting his theory, and I've reserved the second half for Q&A. So feel free to start dropping questions in chat, and to help me locate them, please prefix your question with a capital Q. Just makes it easier to find. This session is going to be recorded and will be uploaded to YouTube. So if you want me to read your question, just indicate so in the chat. Otherwise, I will call on you to unmute and ask your question. And if you see a good question, you can upvote it with a +1. If you're unfamiliar with the protocols here, don't worry. It's really easy to pick up. Just follow along in chat. And with that, buckle up as we're in for a ride. Welcome, Frank. Frank, you're on mute.
Oh, that's a famous thing we hear on Zoom a lot, right?
Yeah.
I'll start over. My name is Frank Heile, and I'm very happy to be here and share my model of consciousness with you. I'd like to thank David and Peter for inviting me and thank all of you for showing up. Now, I need to, did I already share screen or not?
Not yet.
Let's see, share screen, here we go. Okay, now can you see my screen? Okay, so as I go through the talk here, if you have a question about a particular slide in this talk, please feel free to note the slide number, which is shown right here in the lower right-hand corner. So that's how you can know what slide number it is, and then I'll be able to get to that slide when I answer the question. First of all, this explanation of consciousness is based on 3 core ideas. There's the good regulator theorem, the proposed 2-agent model of the human brain, and attention schema theory of consciousness proposed by Michael Graziano, a Princeton neuroscientist. Here's an outline of the talk. You can see there's a lot of ground to cover. So let's dig in and start with the description of agents and world models. The definition of an agent is that an agent is an entity that has goals, has a way of sensing the world, and a way to make changes to the world to achieve those goals. So by this definition, for example, a thermostat is an agent. It has a goal of keeping the room to a certain temperature. It has a way of sensing the room temperature, and it has a way of changing the room temperature by turning the heater on or off. So thermostat is an agent. A human being is an agent. We have lots of different kinds of goals, but the 3 main categories of goals are to survive, to reproduce, and to be social. And the And we can also sense the world, and we can also make changes to the world. So human beings as a whole are an agent. And then I'm going to take that human being agent and break it down into 2 subagents, and that's what this model will be about. So a not very well-known theorem from control theory says that every good regulator of a system must be a model of that system. Now, in this theorem here, the regulator is an agent, and the system is the agent, is the world that that agent is trying to control. So it's trying to achieve its goals in that system. And so this is saying that every good agent needs a model of the world that the agent is operating in. Now, the theorem says a good agent is an optimally simple agent and an optimally effective agent. If it's optimally simple and optimally effective, that's when this must be a model of the system comes in. And that's saying that the states of the agent are one-to-one with the states of the world. There are no extra states in the agent. That's part of the optimally simple claim here. Now, evolution is not known for making optimally simple and optimally effective agents like humans. So we definitely are not optimally simple. So instead of being a model of the world, we simply need to contain a model of the world. And that's what the theorem also says, that if the agent is more complicated than the simplest possible agent, it will contain a model of the world plus other things. And we definitely contain other things besides our model of the world. So each human is an agent that's maintaining a model of the world that they're living in. And since the human is part of the world, it needs to have a model of itself in that world. And that's called the human self model. My self model is my model of me in the world that I'm in. So each human contains a model of the world. And the model of the world contains several different things. It's got a sensory model of the world I get from my senses. There's an abstract conceptual world model that I build up from language and reading books and things like that. There's the memory of my sensory and language inputs in the past. That helps me predict the future states of the world by seeing how it changed in the past. And I make models of the other humans that I know, my wife and my daughter and my friends. And in addition, I have a model of myself. So this is the self model of the human themselves. And that self model is part of the world model. Now, the question is, do we experience the world directly, or do we only experience our model of the world? And colors can help answer that question. The way colors work is that there are 3 different kinds of photoreceptors in the eye. One that's sensitive to short wavelengths of light, one to medium wavelengths, and one to long wavelengths. And each of these different sets of photoreceptors effectively makes a black and white image of the world in that wavelength range. So you have these 3 black and white images, and that's the information that is being sent to the brain from the eye. So the brain is receiving that information, and the brain takes that information and makes this beautiful picture here. So all the colors that you're seeing there in that picture are not colors that are out there in the world. These are the colors that are created in your brain when it's processing that information. They are not out in the actual physical world. So the colors that we experience are basically equivalent to a wavelength of light or a range of wavelengths of light, but it's not a one-to-one mapping. And you can see that by looking at a color optical illusion. So in this optical illusion here, the left rectangle and the right rectangle are actually the same color of green, but they don't look the same. To me, the left rectangle looks a bluish green, and the right rectangle is a yellowish green. To prove that they're the same, I'll erase the purple and orange bars over the bottom half of this image. Now you see that there are 3 different green experiences from exactly the same wavelengths entering your eye, but you get 3 different experiences from those wavelengths. So this is showing that the brain's model of the world can differ from the actual world. And what we experience is the model of the world. We don't experience the actual world out there. We experience the model of the world always. More evidence that we experience our model of the world comes from visual acuity. The visual acuity is highest in the center of vision, and it goes down rapidly as you move angles out from the center of vision. So, you know, in the periphery, you'd be legally blind if you had that vision everywhere in your field. And then on top of that, there's an actual blind spot where you can't see anything at all. And yet, when we look out at the world, we experience something like this. So if you keep your eyes on that green star in the center of the image there, the houses nearer that green star, you can see very well because that's your center of vision that has high acuity. But all of the houses in the row there look like they're crisp and in focus. And in fact, if you go beyond the edges of your computer screen, everything in your room there seems like it's crisp and in focus. You don't see blurriness as you go out to the edge of your periphery there. So what we experience is crisp and in focus, which is not what the eyes are sending to the brain. They're sending something like this, where it gets blurrier and blurrier in the periphery. And in addition, there's the blind spot. The reason we don't experience the blurry vision and the blind spot is because what we experience is our model of the world. And the model of the world knows that the entire world is crisp and in focus, because if you move your eyes around in that world, it can see that they're all crisp and in focus. So it gives you that experience, even if it doesn't have the information necessary to actually tell you exactly what's there. So you always get that crisp and in focus view of the world. Another example comes from rapid eye saccades. This is where you move your eyes quickly from one place to another. So if you do that right now in the room, move your eyes from one place to another. When you do that, do you experience the whole world moving around as you move your eyes? No, you experience a stationary, but the image that's being projected onto your retina from your eyes when it's moving like that are changing radically. And yet we don't experience that as the world moving. We experience that the world is stationary because we are experiencing our model of the world, which gets updated by the eyes there. In addition to that, during the times when your eyes are saccading, you are actually blind. You can't see anything. And you can prove that if you go home and look in a mirror up close, get up close to a mirror and look at your left and right eye and rapidly saccade back and forth from left eye to right eye. When you do that, you will see that the image in the mirror there is always stationary. It never moves. So you never see when the eyes are moving. You never can see anything. You can prove that to yourself by using your cell phone camera, your cell phone as a mirror, using the front-facing camera. Do that same experiment into your cell phone. You will see eye motion there because there's a processing delay between going from the camera to the image on the screen there. And that allows you to see the movement of the eyes after you're not blinded anymore. Now I'm going to try to demonstrate that every sensory experience that we have is totally arbitrary. In vision, for example, the photoreceptors of the brain take information, they pass it on to neurons in the brain, and that gives you the experiences of red, green, or blue if you're looking at three different objects. Now imagine that we could do a magic experiment and go into the optic nerve there and swap all the fibers around. If we did that, then what used to be experienced as blue is now going to be experienced as red, and red to green, and vice versa. So those colors are, if it did it to me as an adult right now, it'd be a very strange world to live in. But if you did it to me as an infant, I wouldn't be able to tell that I was any different than anybody else. Because, you know, I can still distinguish the same colors they can. I can still react to the colors in whatever way I want to react to them. And so this shows that the colors that we actually experience are completely arbitrary. So the colors that we experience are arbitrary. And the same thing applies to all of our other senses. For example, the warm and cool touch that we experience when we touch things with our hands, those are arbitrary. There's nothing warm about the warm objects or cool about the cool objects. We've come to identify them that way because of our experiences, but those are arbitrary experiences. And furthermore, when we experience our own body, what we were actually experiencing is our self-model in the model of the world. We aren't experiencing our body directly, we are experiencing our self-model. So I hope you can conclude with me that we are human self-models living in and experiencing our model of the world. Now, perception is commonly said to be about identifying and interpreting sensory information. I think better definition is that perception is the experience of our world model. Now let's talk about the two-agent model of the human brain. So the controller is the first agent and it controls the body, and the modeler is the second agent. It creates the model of the world. In particular, the controller produces all behaviors and speech. It produces the inner voice and inner visualizations that we experience, and it produces feelings and emotions that we experience. Now, the modeler is required by the good regulator theorem, and the modeler includes both a sensory and abstract conceptual model of the world. And these are not really two separate models. There's really a continuum from low-level sensory concepts up to the completely abstract conceptual world. For example, in vision, one of the first things the vision system does is detect edges out in the screen, and then it connects multiple edges together to give you objects, and then it surfaces, I mean, and then it connects multiple surfaces together to give you objects. Edges, surfaces, and objects are abstract concepts. And so we start with concepts right at the beginning of sensory perception and all the way up. Now, the other thing besides the model of the world that the modeler does is it directs attention appropriately. And this is the only kind of action that the modeler takes, and we'll talk a lot more about that in this talk. So here's a block diagram of the two agents. The human as a whole is an agent, and the human's inputs are the sensory and language inputs on the left, and the outputs are the control of the body and the language outputs on the right. The modeler is the agent that constructs the world model that's required, and it takes the sensory inputs to produce the sensory world model, the language inputs to create the conceptual world model. It directs attention, and it also has intuition, and it has the goals and self-models of all three agents, the human, the modeler, and the controller. Then there's the controller that controls the body and produces language output. It also produces the inner voice and visualization, and those are called thoughts in general, and it produces the feelings and emotions. Now, if you notice, all the inputs to the modeler are all the things that we can be consciously aware of. And the other thing that the modeler does is it directs attention, and when it directs attention, it's taking the most important part of the world model right now and moving it across this interface to the controller so that the controller can do what it needs to do in the world. So let's look at attention mechanisms. The directing attention to an object results in an experience of awareness of that object. So for example, if I ask you right now to direct your attention to your feet, you might notice some tingling, or you'll notice the feeling of your foot, your shoe on your foot, or the pressure of your foot on the ground. Those are all sensations that were always there, but you weren't aware of them until you directed your attention to them. Now in the visual world, the main way we direct attention is by moving our eyes around, because we want to get the highest acuity part of our eye to look at objects. So we move our eyes around. But even without moving your eyes around, you can direct peripheral visual attention using your eyes. So this is the focal attention mechanism, what I'm describing here, because you're focusing on one particular object of the world. And this gives us the focal awareness experience. So the neural mechanism is the function. I'm sorry, I'm repeating myself. So here's an example of peripheral visual focal attention and focal awareness. If you put your eyes on that green star there, keep your center of vision on that green star, I'm going to ask you two questions, and don't move your eyes when I ask the questions. What's the color of the house on the right of that star? And what's the color of the house on the left of that star? In order to answer those questions, I think you would have experienced that you had to direct peripheral visual attention to the house on the right and the house on the left. Okay, so that's how you direct peripheral visual attention. Let's look at two models that are part of the focal attention mechanism. Now, the focal attention mechanism is billions and billions of neurons in the brain, and it connects the back of the brain to the front of the brain because the sensory areas are in the back and the action areas are in the front. And it's a very complicated thing, and the modeler has to control it. Now, the good regulator theorem says that anytime you have a complicated object that needs to be controlled, you will control it best if you have a simplified model of that object. And the focal attention schema is the simplified model of the focal attention mechanism. Now, don't get bothered with the word schema. That's the word that neuroscientists like to use when they're talking about a model. So this is really a focal attention model of the focal attention mechanism. Now, the focal attention schema includes the modality. For example, was it the bodily sensations or a vision that you were that you were paying attention to? The location of the attention target, like your feet or that green star, and the specific features attended. You might be looking for the color or the shape or the texture of the object, for example. And I'm going to call all those together the location arrow. And when I'm talking about visual attention, I'll be actually drawing an arrow on the screen pointing to what you're paying attention to. And then there's the focal model. And this is the actual contents of awareness of the focal attention mechanism. So the two objects are the focal attention schema and the focal model. Now let's look at how they change when you direct attention. We'll use the example where you're keeping your eyes on the center star, and that's why the black arrow is pointing to that house. And when you direct attention to the house on the right, there's an additional arrow pointing there, or the house on the left, and then back to the center. Most important thing is that the world model didn't change when you directed attention. The world model stayed exactly the same. The model that did change was the focal model. And this, when you were directing attention strictly to the center house, you couldn't really see the house on the right or the house on the left. But when you directed peripheral attention there, you could see some of the house on the left and some of the house on the right. So the focal model changes as you direct attention, but the world model stays the same. Let's review what we know about focal attention and focal awareness. The focal attention schema is a simplified model of our focal attention mechanism. And the focal attention mechanism gives us that focal awareness experience, the colors and things like that that we're seeing out in the world. If you combine those two together, you get essentially the statement of attention schema theory, because attention schema theory says that the focal attention schema is a simplified model of the focal awareness experience. So if you substitute that second statement into the first statement, you get the statement of attention schema theory. So let's apply attention schema theory to an agent. If an agent is claiming awareness of an object, then in the experience that the agent is having is that the self model of the agent has focal awareness experience of the focal object, of the focal model, whatever the focal model is. So that's the experience that they're having. Attention schema theory says that the awareness experience is essentially the same as the attention schema. So the focal attention schema is the model of the focal awareness experience. So it's the best model that we can have of the focal awareness experience is the focal attention schema. And so it's essentially saying that the focal attention schema and focal awareness experience are the same thing. So now let's talk about a very different kind of awareness, which I call diffuse awareness. We'll return to our favorite picture here and keep your eyes centered on that green star there. But this time, instead of directing peripheral focal attention, try to just enlarge your attention and pay attention to the entire screen there. And in fact, enlarge it more and out to every part of the room that you're in there. Just to try to take all that in at the same time. And that's the diffuse awareness. Now you can see lots of objects out there in the world, but you'll notice that if I asked you to name an object in the right half of the visual world there, you will have to actually direct peripheral visual attention to that object in order to name it. And the same for an object in the left half of the world. So you can have that awareness, you can have that experience of the entire world out there in front of you visually, but you can't talk about it without directing focal attention. And that's an important part of this talk here. So you have to have focal attention in order to do anything with your diffuse awareness. Otherwise, you can just experience it, and that's all you can do. So let's review the models used by the focal attention mechanism. We had the focal attention schema and the focal model. For the diffuse attention mechanism, I'm going to propose similar models. So I'm proposing a diffuse attention schema and the world model, because you're aware of the entire world when you're using your diffuse awareness. Now I've drawn the diffuse attention schema as a ball of arrows, and that's meant to indicate that it's paying attention to the entire world all at the same time. So it's not just focusing on one point or another, it's paying attention to the entire world. And that's what the ball of arrows is trying to indicate. And that's my hypothesis here. So there are four models that the modeler is creating. We have the world model, which we started with. That's what the good regulator theorem said we had to have. When we direct focal attention, we get the focal model, and we also get the focal attention schema, which is the model of the focal attention mechanism. And now I've added the diffuse attention schema, which is a model of the diffuse attention mechanism. So these are the four objects, and these four objects together constitute the complete world model that the modeler is creating. This is everything, the entire model of the world that it's creating is these four objects here together. This is the complete world of the modeler. Now let's extend attention schema theory to this new diffuse attention mechanism. So the diffuse attention schema is a model of the diffuse attention mechanism. The diffuse attention mechanism gives us diffuse awareness experience. So we extend attention schema theory to say that diffuse attention schema is a simplified model of the diffuse awareness experience. So when the modeler is creating that diffuse attention schema model, that process of creating that model is exactly the same as our awareness of the diffuse awareness of the world. Let's apply this extended attention schema theory to an agent. So again, if an agent is claiming a diffuse awareness of the entire world, then in self models, it would be the self model plus the diffuse awareness experience of the world model. That would be the actual experience of it. And the attention schema theory, extended attention schema theory, says that that's the diffuse attention schema that you're experiencing there. So that's the model. Now, it turns out that, however, that there are two different subtypes of focal attention. second, there we go. So there's top-down focal attention. This is where the attention target is chosen by the controller. The controller says, pay attention to that green star. It was my controller that told your controller to pay attention to the green star. Bottom-up focal attention is where the attention target is chosen by the modeler. And the modeler will do this, for example, if there's something surprising that's happening in the world that didn't expect to happen, it'll bring that to the attention of the controller, because the controller may have to do something about that. Or if there's some object out there in the world, which was one of the goal targets of the controller, it will bring that to the attention of the controller. Now, I'm proposing that the diffuse attention mechanism also does this bottom-up focal attention mechanism. It's the one that chooses the target for the bottom-up focal attention. So we've got two functions right now that are applied, that are assumed to be part of the diffuse attention mechanism. And I'm adding a third here, which is that it also updates the world model based on the current sensory inputs. So those are the three functions that I think the diffuse attention mechanism implements. And my reason for thinking that all three of these, that it does all these, is that all three of these actions require that attention is paid to the entire world model. For example, if there's some sensory change out here in the physical world, the diffuse attention mechanism would become aware of that, and it would update the world model to correspond to the new sensory input that's coming in. In the process of doing that, it may find that that was a surprising thing that it needs to make a bottom-up focal attention target about. And then in addition to all that, it gives you the diffuse awareness experience when you expand your awareness out to the entire world model. So if we have two different, we have two different mechanisms in the modeler's complete world: the focal attention mechanism, and there's the functions it implements, and the diffuse attention mechanism and the functions it implements. Now, the interface between the modeler controller must be part of the focal attention mechanism, because that's what is given to the controller from the modeler. So the focal attention mechanism spans from the modeler to the controller through that interface. And that's how the focal models and the focal attention schema gets to the controller so it can do its work in the world. The diffuse attention mechanism is only in the modeler. Remember, when you tried to name one of the objects out there in the world, that's trying to use your controller to name it, you had to have focal attention in order to get to that object to name it. So the diffuse awareness experience is completely confined to the modeler and nowhere else. So in our diagram here, the diffuse awareness experience is only in the modeler, whereas both the controller and the modeler can have the focal awareness experience. And in fact, these two different mechanisms have a connection, because when the modeler is making a bottom-up focal attention target, something from the modeler, from the diffuse attention mechanism, is going up to becoming a focal attention mechanism, is telling the focal attention mechanism about this new target that it should pay attention to. So some final points about awareness in general. All these diffuse attention schema arrow locations determine all possible attention targets. And that's the only kind of things that we can be aware of, the things that are pointed to by that ball of arrows. And each of these possible attention targets directly affect the world model. The reason that these are possible attention targets is because they can directly affect the world model. And that's why the world model never changes without the possibility of the controller being aware of why the world model changed. Now, the controller can't be aware of all of those things because things are changing too rapidly, but anything that changes the world model can be brought to the attention of the controller. And that's what the functions of those arrows are. This means that the great majority of processing that happens in the brain is going to be completely unconscious. The modeler itself is unconscious, and except for the world model itself, that's the only part that's conscious to us. And we're only aware of the sensory and language inputs when they affect the world model. All the other processing of the modeler is completely unconscious. If you look at the controller, everything is unconscious except for thoughts, feelings, and emotions. And that's because thoughts, feelings, and emotions are inputs to the modeler that can change the world model. So let's review what we know about the two different attention mechanisms. The focal attention mechanism implements top-down and bottom-up focal attention, produces the focal awareness experience, and according to attention schema theory, it's a model of the focal awareness experience, the focal attention schema. On the other hand, the diffuse attention mechanism has three functions that it performs. And according to extended attention schema theory, its diffuse attention schema is a model of the diffuse awareness experience. So let's apply attention schema theory to agents. We're going to apply it to the modeler, the controller, and the human as a whole. So first of all, in order to apply attention schema theory, you have to know what the self-models of the agents are. So in the abstract conceptual world, the model of the controller is the I, me, my concept. And that's the name I made for that. And it's the complete autobiographical narrative history of me, of everything I know about me. And Douglas Hofstadter claims that this is probably the most complicated object in our brain, complicated concept in our brain. And I agree with him, because it's you know, we're all about me. I really care about me. So I need to have a lot of information there about me there. Now that's in the abstract conceptual world. In the sensory world, it's the body schema. Again, this is just a body model. That's what the word schema means. It's a sensory model of the physical body. So those are the two parts of the controller self-model. Now, the modeler self-model, you might wonder if it needs to have a self-model, because it doesn't actually do anything out in the world. So why would it need a self-model? Well, it doesn't do anything in the physical world, but what it does in the conceptual world is to direct attention. So for example, in the focal attention world, in the world of focal attention, it directs attention using the focal, it directs both top down and bottom up focal attention. And it does that by using the focal attention mechanism. And the model of the focal attention mechanism is the focal attention schema. That means that the self-model of the modeler in the focal awareness world is the focal attention schema. In the diffuse awareness world, there's all those functions it performs, and the diffuse attention mechanism is the one that performs them all. And the model of the diffuse attention mechanism is the diffuse attention schema, and the model of the modeler in the diffuse world is exactly that diffuse attention schema. So now we can fill out our model here, the focal attention schema, which is the self-model in the focal awareness world. The diffuse attention schema is the self-model in the diffuse awareness world for the modeler. So let's put these all into a table. There's the controller self-model. Now the modeler self-model is focal and diffuse attention schemas, but according to attention schema theory, that's the focal and diffuse awareness experiences. So it's awareness in general, both focal awareness and diffuse awareness is the modeler self-model. So just think about that. Anytime you experience awareness of something out there in the world, you are experiencing your modeler's self-model. You're experiencing your modeler's self-model. That's what awareness is. And then finally, the human will be some combination of the controller and modeler self-model shown above. Now, attention schema theory says that an agent can only be aware if it has a focal or a diffuse attention schema. That's where awareness comes from the attention schema. Now, it's only the modeler that has an attention schema. And therefore, according to attention schema theory, it's only the modeler that's has conscious awareness all by itself. This means that in order to get a controller to have conscious awareness or a human to have conscious awareness, you're going to have to add the modeler to those other agents. So starting with the modeler itself, the modeler has awareness all by itself, and the self-model is awareness. So when you're applying attention schema theory to the modeler, you use the awareness self-model. The controller is, you have to add the modeler to the controller to get a controller that's conscious, and the self-model you use there is the controller self-model, the I, me, my, and the body schema. Now, the human as a whole is a combination of those two consciousnesses, and it would be some combination of the controller and modeler self-model in various proportions, and we'll talk about that later. Now, first of all, since the modeler is the only agent that is aware all by itself, let's define fundamental consciousness as the modeler's diffuse awareness and the modeler's focal awareness. So that's fundamental consciousness, and that's what gets added to the controller and to the human. Now let's look at the distinction between phenomenal consciousness versus access consciousness, which was proposed by philosopher Ned Block. He said that phenomenal consciousness is experience, and it's commonly said to be the phenomenally conscious aspect of a state is what it's like to be in that state. In other words, it's the quality, it's the redness of red, or the sound of a music, or the pain of a headache. Those are your experiences, and that's what the phenomenal consciousness is. On the other hand, access consciousness is availability for use in reasoning and guiding speech and action. Well, the only agent in our model here that reasons, speaks, and acts is the controller. Only the controller reasons, speaks, and acts, so only the controller is going to have access consciousness. Now, access consciousness is something that we're actually getting better and better at having our artificial intelligence and computers come up with almost human level of access consciousness. You know, we have self-driving cars are essentially doing access consciousness to drive the car. But the hard thing is, what in the heck is phenomenal consciousness? Where does it come from? In fact, philosophers have coined the phrase the hard problem, which is explaining why there is phenomenal consciousness, explaining why there is something it's like for a subject to have a conscious experience. So the hard problem is phenomenal consciousness. And if you have two different kinds of consciousness, you have two different kinds of awareness. And let's look at where these two kinds of awareness occur in our two-agent model diagram. First of all, the diffuse attention mechanism is, there are two different kinds of awareness there. And the diffuse awareness is only in the modeler. So right off the bat, we can say that the phenomenal consciousness of diffuse awareness is only in the modeler. And in fact, there isn't any focal consciousness of diffuse awareness because it has to be a focal awareness to get that. We can also say that the access consciousness of focal awareness is only in the controller, because it's only the controller that can have access consciousness. So the question is, what about the phenomenal consciousness of the focal awareness? Where is that located? It could be in both agents, but I think that doesn't make any sense. It's really got to all be in the modeler. So the modeler can do focal awareness of the focal model, or it can diffuse awareness of the entire world model, and it's all located in the modeler. So that means that phenomenal consciousness is located in the modeler, and access consciousness is located in the controller. Now, if the controller doesn't have phenomenal consciousness, how is it that the controller can report the color of objects? For example, this green apple here. How is it that the controller can report that? If we paid attention to the model, the focal model is now going to the controller, and the focal model is not just the images I've drawn it there, it's actually all the information that the modeler knows about that image. So for example, it would know that that particular pixel right there has a property called color, and the word label for that color is lime green. So the controller is given that word label, and that's why the controller can say that's a lime green pixel right there. Now, at the same time the controller has that word label, the experiencer has the modeler has the experience label of that lime green color. So there are two different labels for this color property for this particular object, the lime green color and the words lime green. Similarly, there's a green apple object in this focal model, and there's a brown stem object. So all that information is given to the controller by the modeler once it's constructed its model of the world. So can this model of consciousness provide an answer to the hard problem of consciousness? Let's take a look. From the controller's point of view, he thinks I'm the body, and I'm this I, me, my that's inside this body. And when I look out through my sense organs, I see a green apple out there. So the experience of the green apple seems like it's out here in the world. And this is a hard problem to explain. How can an experience exist out in the world? And that's why, for example, a lot of people try to extend the physical world to say there's actually consciousness in the physical world, because they don't understand how they can get experience out there in the world. Now, the truth, according to my model, is that the controller is the body, but it contains the modeler, which is constructing the world model. And in that world model is the controller self model, which is the body schema. So the body schema is what's actually having the experience. And the information comes in from the external world through the sense organs, and the modeler constructs the model of that object. So it constructs that green apple object there. So when we direct attention to that object, we can then have the green experience, and it seems like it's there in that object there. There's a green color experience in that apple. But that's not actually the case either, because the experience, remember, comes from the focal attention schema, and the focal attention schema is there, that object there. That's where the awareness comes from. So the awareness of that green, the experience of the green, is in the focal attention schema. It's not in the focal model that's part of the world model. This is easier to explain because the green is the label for the color property of the object, but the experience is in the focal attention schema of the complete world. It's not in the actual world model at all. To make that clear, let's look at the world model, the complete world model. So if there's an apple object that's in our field of vision, it'll exist in the world model, and the diffuse awareness of that green color experience will exist in the diffuse attention schema. If that's also in our focal awareness, if we are actually looking at it, then that green object will be in our world, in our focal model, and the green experience will be in the attention schema there. So objects in the actual world will be in either the world model and or the focal model, whereas the experiences are always in the attention schemas. And notice that the attention schema is not part of the world model or the focal model. It's part of the complete world as constructed by the modeler. That's why awarenesses seem so mysterious and so odd, because they're not out there in the world. They're part of the world model created by the modeler. So now let's begin to, and that's my proposed solution to the hard problem. I'm sure it's not going to convince everybody, but I'm convinced by it. Now let's get back to applying attention schema theory to our agents. So the focal attention schema is a model of the focal awareness, the diffuse attention schema is a model of the diffuse awareness, and the attention schema theory says you combine the self model plus the attention schema and the model to get the awareness experience. So the attention schema model for an agent in the focal awareness is shown here, and this is the sensory experience, and then in words the agent would say, I am aware of the object. And here are the corresponding pictures for the diffuse awareness. And the agent would say, I have diffuse awareness of the entire world. So let's consider using these two kinds of awarenesses at three different kinds of objects. So we'll have focal awareness of an object, focal awareness of a concept, and focal awareness of the self itself. Now, attention schema theory says that the focal awareness is awareness. That's where the awareness comes from. So an awareness of a concept is really recognition of the concept. I recognize that the concept exists and that I've seen it before. So let's use the controller's I me myself model and apply it to these three cases here. So you do the application like that and you end up with I am aware of the object, I recognize the concept, I'm aware of me. For the actual sensory experience, it would be the body schema has the sensory awareness of the object or the recognition of the concept, or the body schema is aware of the body schema. Now let's look at the modeler's focal awareness models. Now remember that the focal awareness schema is awareness of self too. And all these awarenesses are awarenesses of objects or of concepts or awareness of awareness itself. So if you get rid of all the redundant awarenesses here, you end up with a selfless awareness of an object, a selfless awareness of a concept, recognition of a concept, and a selfless, locationless, objectless awareness of awareness. And I believe that awareness of awareness is sometimes interpreted as a sense of presence. So it's a sense of selfless, locationless, non-physical existence. In other words, of presence. So that's what the modeler is going to experience. Now, when you apply the diffuse attention mechanism to the modeler's awareness, you get the self model plus the diffuse attention mechanism plus the object. And the self model is the diffuse attention schema also. And so you get the diffuse attention schema of the world model. And in the case of the self model, there must be an implicit world model there also, because the diffuse attention schema always points to the entire world model. And again, when you eliminate the redundant diffuse attention schemas, you end up with awareness of the world, which is a selfless awareness of the world model, both for awareness of the world model and awareness of the self. Now, non-duality is described as said to occur when one experiences the self-other distinction as an illusion. This is the self and this is the other, and they're exactly the same. So the distinction between those is an illusion according to this model. Now let's try, and the other way of experience non-duality is to say that the world and I are one, and the world and I are one in this case here. So fundamental consciousness is selfless. It is a selfless self-awareness, a focal self-awareness that's selfless, and it gives a sense of presence. And as a diffuse self-awareness, it gives a sense of non-duality. All right, so now let's talk about the possible human self-models. The human contains both the modeler and the controller. So the self-model of the human is some mixture of those two together with different percentages that add up to 100%. My claim is that the normal modern human thinks that they are 100% the controller. They think that they are the ones that move the body, they are the one that speak, they are the one that have thoughts, and they are the one that has feelings. So they are the modeler. They're not even aware that there is a modeler. They think that all I am is the controller. There isn't anything else but the controller. So if you go back to the human self model, that would be 100% controller self model with 0 of the modeler self model mixed in. I claim with some meditation practice, we start to get some of the modeler self model built in. First of all, almost all meditation practices are about directing attention in one way or another. And directing attention is exactly what the modeler does. And the meditation practices are also emphasizing the awareness that results from that directing attention. And that's exactly what the self model of the modeler is. When the meditator is experiencing awareness of whatever the meditation object is, the meditator is experiencing its own self model. That's why some of this modeler self model gets built into the human when you've done some meditation practice. Now, another state of consciousness which is sometimes experienced is the flow state. And I'm going to propose that it's actually going to be an equal admixture, a roughly equal admixture of the modeler self-model and the controller self-model in the flow state. The kind of attributes well, you get, first of all, you get a flow state when you really are absorbed on a particular activity. You know, artists often report being in the flow when they're doing their art, but anybody can get into a flow state when they become totally absorbed by one task. And they point to a loss of reflective self-consciousness when you're doing that. Well, it's the modeler that doesn't have it, is a selfless awareness. So if you're not aware of yourself, that would be the modeler part of you. There's intense concentration on now. That's what the modeler is very good at. It knows about the physical world the way it is right now. And it's not worried about the future or remembering the past. And there's a merging of action and awareness. And the controller is action and the modeler is awareness. So if those have merged, that's why I claim that there's an equal mixture of those two models there. Now, the persistent enlightened states have some similarities to the flow state. And the attributes of the enlightened state are that there's a selfless awareness, non-duality, or a sense of presence. And there's also no sense of agency in the enlightened states, or a lessened sense of agency. So my proposal is that the enlightened states have various percentages of controller and modeler, with more and more modeler as you go to the fully enlightened state. So in the fully enlightened state, you'd be 100% identifying with awareness and 0% identifying with the controller. So let's look at the question of who are you using these 3 proposed models of the human brain. If you control the body, you produce speech, thoughts, and feelings, and you only have focal awareness, then you would be the modern human. Now, if you begin to recognize that you actually, instead of having focal awareness, you actually are focal awareness to some extent, that would be the modern human with some meditation practice. When awareness is totally absorbed by the current task and the actions and awareness are balanced and completely unified, you'd be in the flow state. And in the enlightened state, you would recognize that you are awareness, that you are aware of the body moving, of your speech, thoughts, and feelings, but you have no sense of agency. That would be the enlightened state. Clearly, the fully enlightened state is the fundamental consciousness state because it has the focal self-awareness that gives a sense of presence and the diffuse self-awareness that gives a sense of non-duality. So to finish up, let's review the different kinds of consciousness that we've explained, the phenomenal consciousness and access consciousness. We've solved the hard problem. We talked about modern human consciousness and the effect of meditation on consciousness, the flow state consciousness, and enlightened states of consciousness. Now in part 1, we provided an explanation of consciousness using this model. Next week in part 2, I will attempt to provide an explanation of spirituality. And the first thing I'm going to do in the part 2 model is to rename the modeler as the experiencer. I didn't start off naming it the experiencer because that would be kind of assuming what I want to prove, but I hope I've proved to you that the modeler is the agent in the human that has all the experiences that the human has. And therefore it's appropriate to call it the experiencer. The next thing I'm going to do is, just as we decompose the human into 2 agents, I'm going to now take the controller and decompose it into 2 agents. I call the thinker and the doer. So that there'll be much more about meditation and enlightened states when I talk about next week, my talk next week, and I'll provide a very interesting explanation, an explanation of a rare neurological condition next week also. So stay tuned for that. So I hope to see you all next week. In fact, get some of your friends to come also. Finally, here's the bibliography for this talk. And that's the end of the talk. I welcome feedback, and go to my website and sign up now, and you'll get notifications when there's new content on the website. And hopefully within the next year or two, you'll get notification of the publication of my book. And you can contact me at any time. And thanks for directing your top-down focal attention onto my talk.
Thank you, Frank. That was a lot to process.
Yes.
I'm going to invoke host privilege and ask the first question, and then Rain will be up next. So first question is, Frank, do you believe we have free will? And if so, how does that fit into your model?
I don't believe we have free will. The agent that's making all the decisions, you notice there, was the controller. And I don't think we actually are the controller. I think we are the modeler. That's the person that's having all the experiences. And you know, I think when people talk about humans having free will, they're assuming that somehow it's the modeler that is making the decisions that I make in the world. And it's my conscious awareness that I have in the modeler that's making the decision. The conscious awareness is going along for the ride of whatever the controller is deciding. So the controller makes all the decisions, and the modeler is aware of all those decisions, aware of the thoughts that the modeler is going through there. But the modeler doesn't influence the decision. It's entirely by the controller. And the controller is completely unconscious. It's not a conscious being. So, you know, I don't think that that we have free will at all.
Okay, thank you. Rain, up next.
Thanks. Hi, Frank. Thanks for being here.
Sure.
My controller has a question, and I'm privileged to be able to ask it. So like cognitive science really kind of emerged in the 20th century around the same time or a little bit after computer science. And so computers have been a big influence on cognitive science and its conceptualization of cognition, specifically in modeling it as kind of an individual enterprise that happens within the brain and body. And then in the 90s, cognitive science started to challenge that individualist notion of cognition, and the concept of distributed cognition emerged and helps explain certain things. And I know there's some experiments, I'm not familiar with the details, that show that a lot of what we consider to be functions of a rational being that are functions of a system that is tightly coupled in some ways. And so the model, you could say the model exists in the system or in the agent environment relationship. So all this comes down to a question of what's your view of distributed cognition? And do you think that it's possible for an agent to have a partial model in participation with an environment?
Well, the model is never going to be an exact model of the world. I mean, we can't model every single detail of the world in our brain. So, you know, our perception, for example, has to pay attention to what's the most important things about the world that might affect my survival, for example, or my ability to achieve my goals. And it will only take those and build a world model based on what is the most important thing. So I'm not 100% sure what you mean by distributed model building here. You know, there are incomplete models. I mean, we don't have a complete understanding of a lot of things that happen in the world, but we just do the best model we have and go on with that. So if you want to clarify your question any further, or did I answer anything?
Sure, yeah, I can try to clarify. By incomplete, I don't mean like inaccurate, but rather that some part of the environment is doing part of the cognitive work.
Oh, outside of the body.
Yes. Yeah.
Yes. Yeah. I don't believe that. I think that the body and the brain is doing all the work of building the models. You know, I'm a physicist, so the world is a physical world, and our cognitive world is up here in our brain. It's not out in the physical world. It's not part of the physical world up there, according to my physics.
Thank you.
Peter Lloyd. Could you unmute and ask your question, please?
Hello?
Yes,
Oh, can I ask a question?
sure.
Oh, yes. In this presentation, you mentioned the modeler's self-model, the human model, differs from the world model in regards to sight and touch, you mentioned. I was wondering, A, does that apply also to smell and hearing? And B, are these differences between those two models, are they usually significant, or are they just minor? They can be ignored?
Okay, well, what I meant to say is that the modeler takes all of the world, all of the sense data in, and constructs one single world model. There isn't a visual world model and a sense world model and a smell world model and touch world model. It constructs one world model and it uses all the senses that it can to get the most accurate world model that it can. So there's one unified world model in my model of consciousness here, and that's what the good regulator theorem says. It's a model of the entire object that you're trying to control. So the different modalities supply different information. You don't get color from touch. You don't get temperature from vision. So you use each sense for what it's good for telling you about the world, and then construct one world model from all of those. Does that answer your question?
Okay, I don't think that was Peter Lloyd. Is Peter Lloyd here?
That was Peter B. Lloyd that asked that question.
No, I think that was Claudio Galaxy, unless he's going by anyways. While we're waiting for Peter Lloyd, can I get David Collins to unmute and ask a question? Just a reminder to everyone that just please wait for me to call on you.
Hi, David. Thanks. I'm a longtime meditator, primarily in Buddhist practices, and several years back did some intensive training in the jhanas sequence, synesthetic absorption states that unfold in a set sequence. Quite remarkable, beautiful, lovely experiences. And following one retreat, I was waking up at night in the middle of the sequence. Some part of me knew how to do the jhanas, while it also knew how to do sleep. And this was out of dreamless sleep. So I'm interested in any take you have it from your framework on those levels or modalities of agency.
Okay, well, I can't explain any particular jhana experience in terms of this model. I do have an idea about sleeping though. Basically, when we are aware of things in the world when we're awake, we have a world model in our head that is being constrained by the sensory experiences coming in. So the sensory experiences constrain what we can have in our world model there, visual experiences, auditory, or anything else. When we're sleeping, the brain gets cut off from all the sense inputs. So the brain is now running without any sensory inputs, but it still can have a world model. And when you're in a dream state, you are experiencing your world model free running without any sensory input constraining it. That's why you can get all kinds of strange things happen in a dream that couldn't possibly happen in the real world, because you're now not constrained by sensory inputs. So, and the controller participates in the dreams too. The controller, because if you're in a dream and you're imagining walking someplace, that's like your controller thinking he's walking his body, but the body gets cut off from the outputs of the controller. In the nerve stem, the motions that the controller is telling the body to do get cut off, and they don't go actually down to the muscles. So the controller and the modeler can be working together just like they do when you're in a normal waking state, but you're just cut off from your body output for the controller and you're cut off from sensory input for the modeler. So you could go through the same jhanas in your sleep that you could when you were awake. And the you that's doing that, by the way, is the modeler. That's the modeler is who you think you are, especially if you're an experienced meditator. So I'm not surprised that you were able to access those jhanas in your sleep state as if you were awake. So I think that's my answer. If you have any other.
Well, I'll just tag. Part of what happens in the jhanas is you become appreciative of different levels of quote unquote agitation. So you're generating these states and then you generate less and less. A perspective that was lent me by this experience is how my waking sense, and I may not be using the word the same way you use, but my waking sense of controller or agency is an agitation, is a booted up system. And so it's been just a real gift to have that sort of perspective of how my sense of waking, to use yet another vocabulary, ego, my sense of waking ego is late to the party. It's a generated entity, a generated event or process.
Yeah. Well, you know, agitation makes me think of the controller. The controller is the agent that's doing things in the world. So if you're feeling agitations, and if you're quieting down those agitations, that's I think identifying more and more with the modeler and less with the controller. I mean, the modeler can still be aware of what's going on in the controller, but it's not identifying with the controller anymore. So it's not you that's agitated anymore. And that's the tamping down the agitations, if I'm interpreting what you're saying correctly.
Thanks.
Sure.
Apparently, Peter Lloyd's mic isn't working, so I'll ask on his behalf. He says, surely your entire system could be implemented in a non-conscious information processing system, for example, Chalmers' so-called zombies or digital computer. Surely any computer programmer could set this up in software with zero consciousness. So you do not seem to have addressed the hard problem of consciousness at all.
Okay. Well, that gives me an opportunity to talk about philosophical zombies. Let me do some, let's see here. Got to do the screen sharing again. And let me go down and just look at oops, oh, I pressed the wrong button. Let me start over. It's not as easy to get to these things as I thought it was going to be. Okay, so this is the two-agent model of the brain here. And what's required for consciousness is that you have a model, a world model, a model making system that's making a model of the world. And I think you always have to make a model of the world. Any agent has to be making a model of the world, whether it's explicitly doing it or doing it implicitly. It's creating a model of the world in order to be a good, effective agent. That's what the good regulator theorem says. It says even if you're not trying to make a model of the world, if you are a good agent, you have a good model of the world. So if you have a world model and you don't have conscious awareness, what attention schema theory says is that you have to take away the attention direction attention of here. If there's no attention mechanism in the brain, then you wouldn't have conscious awareness. So if you want to have a philosophical zombie, what you would do is you would take away the attention mechanism here. Now, if you take away the attention mechanism, you're also taking away the connection between the controller and the modeler. So if you do that, then the controller is running free reign without any modeler input from the world model. So it wouldn't be an effective agent. You wouldn't be able to make something like a human that doesn't have directing attention and a connection to the modeler. The only thing you could do would be to share the entire world model here with the controller, with a very fat bus here of essentially giving the modeler the entire world model all the time. That's the only way you could do that without directing attention. But if you're doing that, then the controller has to pick and choose among all the information that's coming in from the world model to see what's the important stuff that it has to pay attention to. for example, self-driving cars, when one of the sensors goes off and says, hey, somebody's coming into our lane here, the self-driving car has to direct attention to that object there and figure out, is there room for me to move out of the way over to the left here, or should I speed up or slow down? Where is there room in the world for me to move if that object is going to hit me, or how can I avoid being hit by that object? So whenever you're having a controller that's doing that kind of operation, it's essentially directing attention there too. So even if you pretend that you aren't directing any attention, you are directing attention if you have a controller that's effective at doing what it's doing. So the more effective the controllers are, the better the model has to be, and the more they have to be directing attention everywhere. They can't be taking all of the information in and not discriminating between what's the important, what's not the important, and somehow doing the correct action based on that. So I don't think that philosophical zombies exist. And, you know, you can, so, you know, in that sense, since every agent has attention, you know, any agent that directs attention has awareness. So all animals have awareness. And if you have a computer program that does construct a world model and figures out what the important part of the world model is and gives it to another part of the program, then I think they are implementing some kind of awareness there too. So I think there's awareness in some of these computer models that we have. I don't think you can make a non-aware computer model because you have to direct attention in a world model.
David Swedlow, next.
Great, thanks. I'm curious, Frank, if you're aware of Donald Hoffman's book, Case Against Reality, his model, and specifically your thoughts about his notion, his hypothesis that consciousness is primary. And it would seem from what you've said that I would expect that you would disagree with him. But there's something of an agent being possible as agents going all the way down to something like atoms or cells that don't have a nervous system, but do seem to have some complex interaction with the system, and then composite agents building up into a more complex agent. So I'm kind of curious how those pieces fit together within your model.
Well, I certainly agree that you can have agents all the way down, at least down to the neuron level in our brain, for example. You know, there's no problem with that. I think that all those theories that posit that consciousness is primary come from the not having a solution to the hard problem. If you don't have a solution to the hard problem, then you have to say that, oh, there's consciousness out there in the world. Every atom is conscious, and I'm building up my consciousness by taking all their consciousness together. And you know, and I don't think that is a viable solution to the problem. So I do disagree with Donald Hoffman. There are some areas where we're in agreement that, for example, he talks a lot about how the agent doesn't have to have a perfect model of the world, and that I absolutely agree with that. The agent just needs a model of the world, and whether it's perfect or not, you know, it doesn't have to correspond to, quote, the real world. You know, from quantum mechanics point of view, the real world is wave functions and particles and all in wave functions and motion around. But you can't make a model of that. You have to make a coarser model where you're taking objects as objects and break those apart. So so there's some part of what Donald Hoffman says that I agree with, and some I don't.
Can I follow up? And sure. I'm going to sneak in my first question, which is kind of like developmentally over time, the complexity of development, that it seems like part of when I look at the agent, the awareness, and the object, the mapping that to seer, the activity of seeing, and then the scene, the object is seen. There also seems to be a seen through, which is kind of the filter that that is the interaction of all of those things that the conscious agent seems to be doing. But developmentally over time, it becomes more complex and it has a greater capacity to include historical experience, to have a different capacity to and complexify the model through a more intense kind of, what is the peripheral? Where are the boundaries and the membranes that conceptually frame my ability to do focused and unfocused attention? Does your model look at developmentally over time, how that model develops into a more complex view?
Like development of a baby to an adult, or are you talking about just?
Yeah, from a baby to an adult, and you know, the different developmental psychologists and those models.
Well, yeah, definitely. You know, babies. The thing about the nervous system is that it has to learn how to interpret the signals that are coming in from it. And it does it by looking at correlations between neurons. You know, the baby is basically doing experiments when it's moving its arms around. It's doing experiments of moving my arms, and then, oh, this is the way the vision changes. Oh, okay, so then the vision and my bodily motions are connected that way. And understanding the way the world works is all done experimentally and experientially as the baby is growing. So that definitely the world model of a newborn baby will be very primitive. There might be some kind of evolutionarily built-in world model, like the mother's breast or something like that, you know, that is built in by instincts. But most of what we learn from our experiences as we were developing and growing up. So there is definitely that kind of evolution.
All right, I've got a question from Ryan Campbell. Could you speak some more about how time consciousness is perceived and distributed across the diffuse and/or focal awareness?
Time consciousness. Well, awareness of time passage is going to be biological. I mean, you know, there's all kinds of rhythms in the brain, and you can be aware of when something has happened and store it appropriately based on when it's happening. If that's what he's talking about, I don't see any problem with that. I don't think there's no time organ that measures time. It's more just the fact that processes take time, and then we can build a model of that as we're building a model of the world.
All right, Ray, could you unmute yourself?
Unmute.
Yeah. Go ahead.
So Frank, my question is, have you done any mapping of this theory, this process theory, to the actual physical sensations going on in the brain, the firing of the neurons, the neurotransmitters, the reward chemicals? Has there been any mapping between the theory and the physical?
Well, the most that I can say is that no. The answer is no, because those are all very low level things. I'm doing a very high level, you know, from 1 mile up from the human brain, that there's just these two agents here. Now, each agent is a lot of different things. I do think the modular is the greater fraction of the brain. I would think that all the lobes except for the frontal lobes of the brain are the part of the modular, most of the modular, and that the frontal lobes are mostly the controller. Although even there'll be mixtures between the functions that's performed. In fact, one single neuron could be acting as a part of the controller in one circumstance. It could be acting as part of the modular in another circumstance. So I don't think there's any bright boundary where you can say this neuron here is in the controller, this neuron here is, I mean, there will be some that are dedicated entirely to the controller and entirely to the modular, but there can be ones in the interface in between them where it's not clear which one they're acting if, and it can vary as experience changes. So I don't have any concrete, you know, neural circuit that is this or neural circuit that's that, no.
So if, let's say, for example, there's a little war going on between me wanting a second piece of cake and wanting to lose weight, how is that resolved in this theory?
That's all in the controller. You got two parts of your controller fighting against each other. The modular has nothing to do with it. The modular is just telling you there's a piece of cake out there. The modular might, you know, if you're asking, boy, that looks like it would taste good, it might remind you of what good tasting cake tastes like, because that's part of the world model. But it wouldn't actually be telling you to eat or not eat that cake. It would all be up to the modular. Now, next week, when we get to two agents, the controller broken down into two agents, those can definitely disagree. The thinker and the doer can disagree. In fact, a lot of what I'll talk about is disagreements between the two of those.
Okay, thanks.
Right. I've got a three-part question from Oswin. Question 1, could you talk about the process to construct this?
To construct my model? Okay, so thank you for asking that, because I started on this model about 20 years ago. And my first model, I called it the language consciousness and the primary consciousness. And the language consciousness is what I'm going to talk about as the talker next week. But the language consciousness is the part of us that uses language and, you know, has language models of the world and things like that. Whereas the primary consciousness was kind of the sensory, I'm blanking on the word, but it's the automatic part of the brain. It's what I call the doer next week is going to be the primary consciousness. The doer combined with the modeler is the primary consciousness. So I had a 2-agent model of a language consciousness and a primary consciousness. And then the next thing I developed was the 3-agent model of the doer, the thinker, and the experiencer. And I had some discussions with some psychology professor at Stanford who convinced me that I was basically biting off too much at once there with all 3 agents, trying to justify all 3 agents all at once. And I realized that I can do this modeler controller theory here, and it can explain consciousness without getting into the spirituality very much. I mean, I did get into it a little bit with the meditation and enlightened states here, but there'll be more about that in the second part of the talk. So it was kind of actually language consciousness, primary consciousness, then the 3-agent model, and then the 2-agent model. And the 2-agent model is all you need to explain consciousness itself. The 3-agent model is more needed for the spirituality, why spirituality developed, what was the problem that spirituality is trying to solve. By the way, the preview is the problem is the thinker. The thinker is the problem. So, and so that was my historical path to here.
So part 2 is about the definition of consciousness. And I'd like to sneak in my own question just as an amendment. Why does consciousness awareness seem to be fundamentally non-physical and not to have a location in space?
Okay, that is due to the fact that well, I guess I should try to share screen again. Am I already sharing screen?
Yeah, I can see your screen.
Well, let me try to, this is the slow way to get there. To any one of my, I probably should have gone out and gotten directly to the page here. Yeah, to this kind of a picture here. So the reason why conscious awareness seems to be non-physical and not have any location in space is, oops, I got the wrong screen going over there. Is because the conscious awareness comes from the attention schemas. And the attention schema, the diffuse attention schema gives you the diffuse awareness experience. The focal attention schema gives you the focal awareness experience. And those things are not connected to the world. That's why it seems like consciousness is something that's not part of the world, because it isn't. This focal attention schema here is not part of the focal model. I hope you can see my cursor moving around here to try to point to these things. So that's why it seems to be non-physical and to not have any location in space, because it's not located in the space of the focal model or the world model here. It's a completely separate model. It's in the complete world that the modeler creates. And that's why you can be aware of your awareness, because it's in that complete world, but it's not part of the actual physical world.
All right, and third part of Awesome's question, which fundamental physics theories are you basing your model on?
Well, actually, see, this doesn't use quantum mechanics. It doesn't use anything, basically. It's almost like engineering rather than physics. Or you could say classical Newtonian mechanics is all that I need here. There's no esoteric things here. There's no quantum mechanics. There's no non-locality. None of that stuff that you get from the, that's not string theory. It's just basically the theory of ordinary objects and building circuits. I mean, the brain is essentially electrical circuits. So it's not, you don't need any any advanced theory to do that.
David Svetlo, would you like to ask another one?
The other question, John Vervaeke's models, I'm curious how much you're familiar with John Vervaeke, and specifically his notion of relevance realization and the 4 ways of knowing is kind of central to his his awakening from the meaning crisis.
I'm not aware of that at all. I'm not aware of that at all. So you'd have to give me enough of an explanation that I can make some response then.
Well, the second part of it, I'll come in with it. The distinction that he makes between intelligence, rationality, and wisdom. I would say intelligence is just very basically the ability to recognize patterns. Rationality is like filtering those patterns down to something more, filtering out some of the noise. There are some of these patterns that are not good patterns, and I can filter those out into a subset. And then wisdom is kind of the ability to look at the frame that I filtered through in order to widen it and narrow it again, to kind of over time to do that. And so that's a very high level view of relevance realization, that ability to say, what's relevant in the frame that I'm looking at? How do I know what's relevant? And that's, again, a little bit developmental. And then the 4 ways of knowing are interesting in that propositional is kind of what we're talking about now. This is language and theory, but then there's also procedural. How do I know things through my practiced learning, through patterns of habit? Perspectival, through different ways of viewing, different agent models, and then participatory, real down at the very base level. That's a lot there, but
that's a lot there. I can give you some reactions to that. For example, I glossed over this in my talk because I had to shorten it to as much as I could, but I claimed that intuition is in the experiencer, in the modeler. I said that intuition is in the modeler, but thoughts are in the controller. And the distinction between those two, I think that might be somewhat relevant to what you're talking about there. The distinction between those two is that when I am trying to solve a problem, my controller is sitting there generating ideas and trying them out, see if that works. No, that doesn't work. Then try something else and do something else. And that's the way that that's when you're doing conscious thought about trying to solve a problem. Intuition is not like that at all. The best example I got is Poincare at one time was working on this math problem, this math theorem that he wanted to prove. He was sure it was right, but he couldn't come up with a proof for it. And he spent a whole day trying a whole bunch of different proofs. This is with this, I'm moving forward to the next week about the thinker. So the thinker is the guy who thinks all those thoughts about, and he uses the language. He's the language expert and the abstract concept expert. So that's the thinker. So the thinker was trying to solve that problem and come up with that theorem, and he failed. He spent a whole day at it and gave up. So he didn't think about it again for a week or two, and then he describes he was walking into a bus, and when he put his foot on the step of the bus, the thought came full blown into his consciousness, the solution to that problem, how to prove that theorem. That was done by the experiencer processing that information. It had all the information that the thinker had, but the experiencer was building the world model of that abstract conceptual world, and it figured out how to produce that thought. And that's when the intuitive thought came to Poincare of how to solve the problem. And he got up on the bus and he thought about it for a second. He said, yeah, that's right. And he filed it away. He didn't even write it down or anything because he knew the answer. And then when he went back to his home, he wrote down the theorem, and there it was, fully formed. So it just came like that in an instant. That's intuition. And that's the experiencer that has that kind of wisdom. The experiencer has the wisdom about the world, and the world for us includes a lot of abstract concepts. Animals don't have a huge number of abstract concepts the way we do. I mean, we get PhDs in abstract concepts here. So, we have a lot of wisdom built up in that experiencer in the abstract concepts, and that's where the intuition comes from that. Whereas the thinking is the controller trying to do one at a time, this idea, that idea, seeing what works. So that might answer 1/10 of your question there, but.
I'll just say that I think his lecture series, Awakening from the Meaning Crisis, is on YouTube. It's 51-hour lectures. It's a lot, but there are a couple of key lectures that are really worthwhile, and it's a very worthwhile venture.
Okay, thank you.
All right, so we're approaching the bottom of the hour, so it's time to wrap up. Thank you so much, Frank, for your presentation. It was wonderful. I'm really looking forward to the next one next week, and I hope to see a lot of you there. And since it ties in so nicely with what we heard today, I'm hoping Evan will unmute and pitch his sense-making series.
Sure, thanks. So can you guys hear me?
Yeah.
Cool. So I am in the middle of a sense-making series inspired by David Chapman's work and textbook. It is well, part of the answer to the last question that was asked, and that is, how do we get from to being able to take advantage of the sort of intuitive problem-solving abilities. Sorry, is my video disabled? Okay,
Now it
well,
is.
never mind. Anyway, yeah, I can't turn it back on, but regardless of that, so the Bridge series is essentially trying to take us to the place where we can do the intuitive processing that was just described in the last question, or the answer to the last question, where we are able to sort of seamlessly switch between using our slow thinking thinker and using our ability to use the underlying world model to direct attention, process things, et cetera, et cetera. So we've already had one series, which is on neurophilosophy. This is quite similar to the material that was presented here, and we will be exploring the implications of this sort of neurophilosophy for embodied practice and how we are in the world next Monday. So I invite everyone to join us for that session.
Great. Thank you. I dropped a link to Evan's session in the chat and a link to the Stoa website where you can view all the sessions and support us on Patreon if you so choose. Thank you all so much for coming today. Special thanks to Frank.
Thank you, everybody.